Well, hello, my algebra people. Here we are going through our study guide solutions for chapter 6. On number 1, we see that we have the first part of a family of 5r to the 5th power is to the power of 0. So we know that anything to a power has to be distributed because there's parentheses, and anything to the power of 0 is 1. So we know this whole value is just 1. Next, we see that we need to take the ticket with r to the negative second power. So that would be 1 over r squared, and 1 times 1 over r squared, it's just 1 over r squared. On number 2, we see that there is a ticket in negative 3. So everybody in the family gets the ticket and the power. So when I rewrite that and distribute the third power to everybody, and then I need to evaluate these. So I know that 2 to the negative third power and t to the negative third power need to take the ticket and go upstairs, and s to the negative third power needs to go downstairs. But I'm not quite done yet. I need to resolve that 2 to the third power, which is 8. So I get 8 times t to the third power over s to the third power. On number 3, I see that there's a ticket to evaluate. So I move that upstairs, but I'm not done yet. I need to finish by evaluating or simplifying 9 squared, which is 81. Number 4, we see that we have a ticket to take, and we take the ticket, and that is all we can do because we don't know the value of m or the value of n. On number 5, everybody in the family gets the power. So I rewrite that, multiplying my power to a power, and then I need to evaluate. So 3 to the 4th power is 81, and then a to the negative 12th power goes downstairs. You have to take the ticket, and then b to the 4th doesn't change because it doesn't have a ticket. On number 6, we can look at this a few ways, but I'm going to go ahead and use our division property of exponent rules, which means I subtract. So then I have d to the 5th power minus a negative 4, which is d to the 9th, and f to the 2nd power minus 6, which is negative 4. So negative 4 has to take a ticket, but d to the 9th stays upstairs. On number 7, I'm going to rewrite this using BER, which is base, exponent, root, or this sends me to the ER. So I rewrite it because E is exponent and R is root, or it's the index of any kind of rooting, and B is base. So 16 is our base, 2 is our root, and to the 3rd power. So the square root or second root of 16 is 4, and 4 to the 3rd power is 64. Completely simplified. On number 8, we see that when we look at our BER here, that it'll be to the first exponent, which means it doesn't change. So we need the 3rd root of 125, and we're going to subtract from that the 2nd root of 9. So the 3rd root of 125 is 5, and the square root of 9 is 3. So 5 minus 3 is 2. On number 9, we can see this as 3 different things multiplied. 343 to the 3rd root, and m6 to the 3rd root, and n12 to the 3rd root. With whole numbers, we would go ahead and use our calculator and root that and get 7, because 7 times 7 times 7 is 343. On the others that are in exponential value, this kind of special division bar literally means to divide. So 6 divided by 3 is 2, and 12 divided by 3 is 4. And we get 7m squared and 4. Keep in mind that if we had had 7 in its exponential value, the exponential value of 343 would be 7 to the third power. And then we could have used the division rule here as well, right? Okay, number 10, we don't have any whole numbers that we are evaluating here. We're just doing exponents. So we know with our first part, we divide by 3. And 6 divided by 3 is 2, and 15 divided by 3 is 5. But we still need to do the second half, which is divide the whole thing by x y to the 5th. So here we have our division rules again, which means we subtract. And 2 minus 1 is 1, and 5 minus 5 is 0, and anything to the 0 power is 1. So we know that the ending value of this is just x. On number 11, we're writing this in standard form, so we put the largest power first, right? So we put it in the order of highest exponent, and then we go down the line. So to the fourth power, second power, first power, and known. Our lead coefficient is 3, and our degree is of the head of the household, which is 4. On number 13, it asked for you to give a monomial, and you could have lots of things in here, but I'm just going to go pretty simple. Monomial is x. Binomial is 2 terms, x plus 1 or x minus 1. And a trinomial has 3 terms, which means 3 things of different degree, right? Different degree. Okay, on number 14, it asks us to combine our like terms because we are adding them, and this is an x squared, so I put that with the x squares, and our 4x, I put that with the x's, and we're adding 10 to negative 6. Add that up, and I get 4x squared plus 5x plus 4. On 15, we have to watch because we are subtracting all of this binomial. So we're subtracting a 3c, and we're subtracting a negative 5, and when we subtract a negative 5, we add, right? So we add that. Same like when we multiply 2 negatives, we also get a positive. So it's not that different. Go ahead and combine my like terms, and I end up with 6c squared plus 14. Because the 3c values cancel each other out. On 16, 17, I'm multiplying. So 16 is a binomial times a binomial, so I know I use box. And I go ahead and multiply 4b times 2b is 8b squared. And 5b times 2b is 10b. 4b times negative 3 is negative 12b. And negative 3 times 5 is negative 15. Combine my like terms, simply getting our solution. On 17, I see it's a monomial times a monomial, so I don't need to box. I'm just multiplying our whole numbers. 3 times 6 is 18, multiplying our x values and our y values. And that's it. Number 18, I'm multiplying a trinomial times a binomial, so I make a 3 by 2 box. Put in all my terms in order and multiply. 4x times 2x squared is 8x to the third. And 4x times 5x is 20x squared. And negative 1 times 4x is negative 4x. 2x squared times negative 3 is negative 6x squared. 5x times negative 3 is negative 15x. And negative 1 times negative 3 is positive 3. I simply combine my like terms, which if you've done this correctly, should be in order. 19 gives us a practical application of how to use our exponent rules. It says a rocket launches from a platform 20 feet above the ground at a speed of 20 feet per second. The polynomial, which is a physics formula, by the way, is negative 16x squared, because that's the gravitational pull, plus 200 times t plus 20. And t represents the height after seconds. So we know the first one's a negative because it has to fight against the gravitational pull. That's why we have negative 16 times the number of seconds in this case is 3 squared plus 200 times 3 in 3 seconds, because we know that's the rate, 200 per second. And then obviously it started at 20 feet above ground, so we have to add that in there. We get negative 16 times 9 plus 600 plus 20. Negative 16 times 9 is negative 144 plus 620, and we get 476 feet is what the height of the rocket will be after 3 seconds. And number 20 asks us to explain in words why x minus 5 squared is not x squared minus 25. Because it's not a difference of two squares, right? It's missing a middle term because it's identical twins. And to show it correctly, I'm going to go ahead and use box to show that we get that middle term of negative 10x. Alrighty, don't forget that I know very well aware that the struggle is real, but it is God who works in you to will and to act according to his good purpose, which is always good for you because he loves you. All right, talk to you guys soon. Bye.